Hi everybody, welcome back to the Feynman technique. Today we'll evaluate this integral that I'm copying directly from the channel Maths 505. I'm not going to be solving it in exactly the same way he did it, and also I'm not going to be using Feynman integration, so this is not a Feynman integration video. But I thought this integral was cool, so I decided to do it. Anyway, he did it a little bit differently than me, but let's just get started. So first step, that natural log x is nasty, so we're going to make the substitution that x is equal to e to the u, and therefore dx is e to the u du. Well, that's going to give us I is equal to the integral from negative infinity to infinity. This whole thing is going to become an e to the negative u squared, and I'll leave it to you to figure out why that is. You just perform the substitution. You'll see that that's e to the negative u squared. And then we'll have arc tangent of e to the u, and then we'll have over e to the u, but that will cancel with this e to the u, so we'll just have du. Okay. All right, so let's split that up into two separate integrals. So this, well, I'll write it down here. So this is going to be equal to the integral from negative infinity to 0 of e to the negative u squared, arctangent e to the u du, plus the integral from 0 to infinity of e to the negative u squared, arctangent e to the u du. All right, let's take u to negative u in the first part of our integral right here. So that would give us that would be a positive infinity, that would be a negative 0. This would remain e to the negative u squared. This arctangent e to the u would become arctangent e to the negative u. And then we'd have a negative du, but we'll use that to switch the bounds. Okay, I hope this is all making sense so far. All right, now here comes the time to break out a trig identity that I derived in a previous video. The trig identity is this. Arctangent of 1 over x is equal to pi over 2 minus arctangent x. And we'll recognize that this e to the negative u is nothing but 1 over e to the u. So this expression right here, this arctangent of e to the negative u, will become pi over 2 minus arctangent of e to the u. And I know that's not the easiest to read, but that's why I'm saying it out loud also. So now we have this, and you guys are all seeing that something really nice is going to happen. This whole second part, this e to the negative u squared, this negative e to the negative u squared times arctangent e to the u will cancel with this one. So we can literally just say that this is equal to the integral from 0 to infinity of this plus this, which is just pi over 2 times the integral of e to the negative u squared du. And we know that this is half the Gaussian integral, which is the square root of pi over 2. So all in all, I is equal to pi to the 3/2 over 4. And let me double check that. No, I'm sure that's right. So anyway,